In number 7, we see we have 7 and 8, we've got cube roots. So let's go ahead and combine what's underneath the cube root symbol. 3r cubed over 9r squared. We're going to simplify what's under the cube root. 3 divides evenly into 9 3 times. Then we have r cubed, so we think about that as r times r times r over r squared, which means we can cancel 2 of those r's, and we're left with 1 r in the numerator. So when the dust settles here, we see we have the cube root of, the only thing left in the numerator is that r, and the only thing left in the denominator, since the r squared got canceled, is the 3. So we have the cube root of r over the cube root of 3. Now, just like I said in the last video, you're not allowed to leave any irrational numbers in the denominator. And so we have to multiply top and bottom by a strategic number here so that the denominator doesn't have any more radical signs in it. So the cube root of 3, you might think, well, let's multiply by the cube root of 3. Well, then we'd have the cube root of 9. That's not a perfect cube. So we see we have 3 to the first power. We need 2 more 3's because we have to now, since this is a 3 and the root is a 3, we need to make sure we have 3 3's, or a group of 3 factors, which the first factor is a 3. So we're going to multiply top and bottom by the cube root of 9. Cube root of 3 times 3. I'll put 9 up there. 9 is equal to 3 times 3. I just wrote it as a 9 up there because I knew I'd be multiplying it by the r, and I wrote it as 3 times 3 down here just to emphasize the fact that now we have a group of 3 and we get to pull it out. So that's kind of a tricky little thing we had to do there. So the cube root of r times the cube root of 9 is the cube root of r times 9, which we're going to write that as 9r. The cube root of 3 times the cube root of 9 is the cube root of 27, but we see we have a group of 3, so we just pull that 3 out. Your tendency here, I notice students, they think they have to do more than that, but if you keep it simple, the cube root, if there's any number under the cube, if there's a group of 3 factors that are the same underneath that cube root, then you can pull them out. But we need 3 of the same factor since that's a 3. That 9 right there underneath the radical, every time you've seen that, you've pulled out a 3 because it was a square root of 9. But the square root of 9 is 3, but the cube root of 9 is just left like that, the cube root of 9. And finally, we have our last problem, and we can see we can't cancel anything yet, so let's go ahead and rewrite the whole expression underneath one cube root symbol. So we're going to have a 3x to the 4th over a 48x squared, and we know that 3 goes into 48 16 times. X squared goes into x to the 4th x squared times. So x to the 4th over x squared is x squared. 3 over 48 is 1 over 16. So let's not lose sight of the fact that we know how to simplify fractions. What's left in the numerator is an x squared. What's left in the denominator is a 16. We're going to break that up so we can isolate that denominator and see what we have to do to it. The cube root of 16, it's not a perfect cube root. 16 is not a perfect cube. So we have to multiply top and bottom by something. Let's think of that 16 as 4 times 4. So we need a group of 3 4's. Well, we can do that by just multiplying the denominator by the cube root of 4. Now we'll have 1, 2, 3 4's that now this whole thing multiplied together would just give us 4. And then if we multiply the denominator by cube root of 4, we have to multiply the numerator by cube root of 4. And we end up getting, in the numerator, cube root of 4 times x squared underneath the cube root. And we multiplied the denominator by cube root of 4 so that we would have a group of 3 4's that we just pull out, and that's it.